Okay, for number 8, I'm going to try the same thing and see if it factors by grouping, but I quickly see that it doesn't. I get 1, -8, and -8 does not, -8 times 1 does not give me -12. So this method does not work, okay? So I'm going to find the factors of the P's and the Q's. Alright, so factors of 12 are 1, 2, 3, 4, 6, and 12. Q's are just plus minus 1. So because Q is plus minus 1, then P over Q is just the set of the list in P right there. So I'm going to start with 1. 1, 1, -8, -12. Bring down the 1. 1, this gives me 2. 2, this is -6. So this isn't going to work, right? Try 2. 1, 1, -8, -12. Bring down the 1. 2, 3, 6. -2, -4, -16. So that's not going to work. Try 3. 1, 1, -8, -12. Bring down the 1, 3, 4, 12, 4, 12, and this one works. Okay? So now what does that mean? That these three numbers here, this means x squared plus 4x plus 4. And this is a perfect square trinomial because the square root of x squared is x, square root of 4 is 2. If you multiply and double, you get 4. You get this term right here. So I just put a plus and a square. So what is it? T of x? T of x equals x minus 3 and x plus 2 squared. So that means that my zeros are 3 and -2. Alright, so number 11, I listed the factors, the P factors and the Q factors. And because Q is plus or minus 1, then my P over Q factors are just going to be that list right there. So I'll start off with 1. 1 minus 2 minus 3. So now it's a fourth power, fourth degree. So that means that we could end up with 4 zeros. Okay? Bring down the 1. 1 times 1, -1, -1, -4. -4, 0, 0, 4. Okay, so this one does not work. I'll try 2. So 1, -2, -3, 4, and 4. Bring down the 1. 2 times 1 is 2. 0. 2 times 0 is 0. -3. This gives me -6. -2. -4. And this one works. Okay? This one works right here. Now I'm going to try, because, see, this here is not a quadratic, so I can't stop right there. So I'm going to use 2 again, because if it worked once, it could work again. It doesn't always happen, but sometimes it does. So I've got to just give it a try. But now I'm going to use the reduced polynomial. Okay, so bring down the 1. 1 times 2 is 2. 2 plus 0 is 2. 2 times 2 is 4. 4 minus 3 is 1. 1 times 2 is 2. And it happens to work. It worked again. Okay? And so now I have a quadratic. X squared plus 2x plus 1. So this one, this is also a perfect square trinomial. The square root of x squared is x. Square root of 1 is 1. When you multiply that and double, you get 2. So plus and then square. So that's how that x squared plus 2x plus 1 factors. So h of x equals x minus 2. And because I got 2 of them, right, I got one here and I got one here, that means I have this factor right here twice. So I'm going to put a square right here. And then x plus 1 squared is what I got from the quadratic. So my zeros are 2 and -1. Their multiplicity is, in both cases, it's 2. So if you were to sketch this real quick, let me just 2, -1, this would be 2. This would be -1. It's x fourth, so it's up, up. So it would do something like this. Like that. Where this number right here would be 4, the y-intercept. Okay, that's what all this means. Okay, so number 12. I listed the factors of 4 that those are your P numbers right here, 1, 2, and 4 because of that 4. The Q numbers, because this is a 1, it's just plus or minus 1. And anytime you have Q being plus or minus 1, then the ratio of P over Q is just simply that list right there. Because like I said before, I'm going to take these numbers over these numbers, and you're going to end up with these numbers all over again, okay? So this list is this list. So I'll start with 1. Now I need some placeholders here, right? Because I've got a 4th, I don't have a 3rd, I have a squared, I don't have an x, and then the 4. So bring down the 1, 1, negative 4, negative 4, negative 4, and 0. So it worked. Just like before, I'm going to try that 1 again. I don't know if it's going to work, but I should try it again. So I'm going to take the new polynomial, the reduced polynomial, and use 1 again. Again, no guarantees that it's going to work, but you should just try it anyway. So bring down the 1. 1 is 2. Negative 2. So it didn't work. Okay? So it didn't work again. So now I'm going to go to 2. Okay? I'm going to go to 2. And so 1, 1, negative 4, negative 4. Bring down the 1. 1 times 2 is 2. 3, 6, 2. 2 times 2, 4. And it worked. So it worked. Okay? Now this is a quadratic, so I'm going to factor it. Remember, this is x squared plus 3x plus 2. Factors of 2 that add up to 3 are 2 times 1. So I'm going to write f of x equals x minus 1, x minus 2. And x minus 1, x minus 2 comes from this 0 and this 0 right here. So that's how I got x minus 1, x minus 2. From this quadratic right here, I'm going to get x plus 2 times x plus 1. And so this is the factored form of f of x. So the zeros are 1, 2, negative 2, negative 1. Or you can just write them, since they're opposite numbers, plus or minus 1, plus or minus 2. Same thing. And that's the zeros for that one. So for 16, you have to match the zeros with the polynomial. So take a look at A. It's 2, 3, and 4. So if you look at this one right here, the 0 for this one is 2, 3, and 4. So this would be letter A. Okay. The first one, I have negative 2, negative 4, and positive 3 halves. So negative 2, negative 4, positive 3 halves is B. Okay. For the second one, I've got 1/2, 5/4, and negative 7/3. So that would be C. And then of course the last one, but let's just go through it anyway. Negative 4/5, positive 6/7, and positive 4. So that would be D. Okay. Alright, so for number 19, you're asked to explain the mistake or the error in Susan's answer. Or Sabrina's answer. So her first 0 was right. She had, for this factor right here, she got 0, and that's good. But for this one, x minus 4, what would make it 0? The answer would be positive 4. So this one here should be positive 4. And then for the third factor, x plus 2, the 0 for that one would be negative 2. So instead of positive 2, should have been negative 2.